All right. And I do know that some of them might be a little late because some of them are having to update. I just got a text.
Oh, gotcha. Okay.
So
we'll go through the introductory slides and the housekeeping, and then we'll give them some more time. So good morning, everyone. My name is Aaron Timmons, Mathematics Content Director for Advanced Kentucky, and we're welcoming you to our third content review session for AP Stats. Today, we are lucky to be joined by Kellie Lee from Glasgow High School, and you can access today's handouts at bit.ly/mathcrs. We'll put that in the chat as well for you. But here in the couple minutes here, while we're getting started, we've just got a couple slides to go through. So first, while this online review session is intended for a Kentucky audience, we know that we have lots of students and teachers joining us from across the country, maybe even the world. So welcome to all of you. We will do everything we can to make this as engaging as possible. If you are causing a disruption, you will be removed. And then finally, AP is a trademark registered by the College Board, which is not affiliated with and does not endorse this product. Today, Advanced Kentucky and myself, we're happy to host. So please see our contact information on there, our Twitter, Facebook, emails. If you have any questions, comments, suggestions, please feel free to reach out to us. So you will notice that your microphones and videos have been disabled. So we highly encourage use of the chat. You can put questions out there directly to everyone, out there to everyone. You can direct them specifically to myself or Kellie if you don't feel like posing it to the entire group. And I'll make sure to interrupt Kellie and let her know, and she'll make sure to get answers. So please use the chat, no matter if you're a teacher or a student. Any question, please feel free to ask. And then just a reminder that today's session is being recorded. It will be posted to bit.ly/advky sometime before Monday, so you can go back and see that. Also, we have links for our upcoming sessions as well as our previous ones as well. So with that said, I'm going to turn things over to Kellie. She can introduce herself and then we will jump right in. So Kellie, it's all you.
Hey guys, I am Kellie Lee. I'm from Glasgow, Kentucky. I teach at Glasgow High School. So oh, heavenly days, what have I done? Can you guys see my screen?
Yes.
Okay, so I will tell you that I was telling Aaron I am proficient in Google Meets now and proficient in Blackboard, but somehow, some way, my Zoom capabilities have lost me today. It's like I have had a small Zoom stroke. So please bear with me. So today we're going to cover two topics. We're going to cover the topic of random variables and probability distribution, and then sampling distribution. So the way it's going to go is we're going to do two small hooks or activities at the beginning of each topic to kind of give me an indication of how we need to proceed. So so from some of the other things I've done, I'm going to throw as much stats at you this morning and hope that you get something out of it. Please feel free to use the chat. If you need me to repeat something, please tell Aaron and I, and we will be good to go. So hopefully everybody can see my PowerPoint here. And to give you a little bit of today's objectives for the first hour is to be able to define random variables, and then the probability distribution, to be able to create a probability distribution. Also, we will need to calculate the mean and standard deviation, which is also on your formula sheet. So we're going to talk about how to use your formula sheet every day. Whoops, excuse me. Oh, heavens. And so also we're going to look at how to apply rules and properties of transformation and combining variables, which is a big deal when we start talking about inference and when we get to the second hour of sampling distribution. And then we're going to talk about calculating probabilities like binomial and geometric. Okay, so a couple supplies that you might need. We need a calculator, pencil, paper, and then if you wanted to print off the participation guides, that's good too. So looking at that, we're going to go to the hook. So Aaron, because of the way my computer is set up at this specific second, can you put the Quizlet in the into the chat for them, please? And then I am going to try to remedy my situation here.
All right. There it is, I think.
I think so too. All right, so if you guys wouldn't mind to go to Quizlet, and it's just a small activity. It's kind of like a Desmos activity. I want you to try to look at the words in the definition and match as many as you can. So on your mark it set, let's try to do some Quizlet. Came to doing our Quizlet. And so now let's jump right into a small little mini lesson. And what I mean by a mini lesson is I am going to give you as much information possible. And hopefully I'm timing myself in about 15 minutes or so. We'll see how that goes. So we're going to talk about random variables and probability distribution. So let's kind of think about this game. In a particular game, a fair die is tossed. Okay, so just the six-sided dice. And then if the number of spots showing is either a 4 or 5, you will win. Okay, $1. If the number of spots showing is a 6, you'll win $4. But if you roll a 1, a 2, or a 3, you win nothing. Okay, so let X be the amount of money you win. So we know in a random variable that we take a value, right? And then we can make it quantitative. Okay, so what would that top portion look like? It would look like a 0, right? A 1 and a 4. Okay, so sometimes they ask me, do the numbers have to be in ascending and descending order? And the answer is no. Okay, so, well, we have a 4 and a 5, so that gives us 2 out of 6, right? We have only 1 6 to win $4, and then there's 3 options to win nothing. So the next question that you probably are talking about is it continuous or discrete? And we know it's discrete because it's jumping like lily pads to each specific number, that you can't win like $1.30 with this game. Okay, so the other thing is do the probabilities add up to be 1? And the answer is yes. Are all the probabilities between 0 and 1? The answer is yes. So this little chart here is actually setting up the probability distribution. Okay, so a couple things, and these are the things that were in our little Quizlet. We know that a random variable takes numerical values to describe outcomes of some sort of chance. Okay, so if we were talking about the number of siblings we have, or winning in skee ball, or any of those things, that would be a random variable. So discrete are these fixed set of numbers that have gaps between them. A lot of times we make the generalization that they're integers, right? That they just have, there's no decimals. Continuous can take many values in between, like height and weight and so forth. And then the probability distribution of a discrete variable gives us the random variable and their probabilities. Okay, so we often use, and this is in that blue box, we often use normal distributions for continuous random variables. Okay, so that's when we graph our normal distribution and we shade, and then we would use like our normal CDF from there. All right, so that's kind of the nitty gritty. So then let's talk about how do we find the mean and standard deviation of a random variable. Okay, so this is the actual look of your formula sheet on the AP exam. Give me a thumbs up or a thumbs down if you use this in your classroom. Does your teacher have you use your formula sheet on a regular basis? Thumbs up or thumbs down? Thumbs up or thumbs down? Got one thumbs up. Okay. So remember, your formula sheet is going to be kind of a lifeline. And the creators of the statistics exam have been like super helpful. They want you to not necessarily concentrate on the math portion or what we would consider the knowledge base, but the understanding of what statistics is. So we have the mean and we have the standard deviation. So we have the mu of x, or the expected value of our random variables. And what we're going to do is we're going to take the random variable times the probability. And then that big summation means we're going to add it to the next one. Okay. And that's what we're going to go from there. And then your standard deviation, okay, which we know it's the average distance from the mean. So the way I have some of my students remember it is that we have our value, our x value, minus our mean, and we square it to kind of satisfy that the distance is always positive, and we multiply it by the probabilities, and we continue to do that. All right, so let's take a look at this one. It's just little. So what would the expected value be? So we took 1 times 2 6 plus 4 times 1 6 plus 0 times 3 6, and we got 1. So we would expect to win $1. Okay, so on average. Everybody okay with that? So do not round the expected value. Just so the expected value, you don't have to make discrete. Just put that number down. Okay, so that's a common mistake. Now we have to calculate, and then here's that I word that we use a lot of times, the word interpret. Okay, so you need to know how to interpret standard deviation. I'm going to say it 3 times because it's super important. You need to interpret standard deviation, interpret standard deviation. Okay, it's super duper important. So we would take that first random variable minus our mean, and we would square it times our probability, and we would continue to do so until we have the sum of 2. Now, in the first column here, that is our variance because we have not taken the square root yet. Okay, so we would take our variance, we'd take the square root of 2, and so it's 1.414. Okay, so here is the important part. If we do this over and over and over and over, okay, the amount that we will win will typically vary from the mean of $1 by 1.41 or $1.41 on average. Okay, so that is super duper important. So in my classroom, things that I know are going to be on the AP exam, I indicate by these light bulbs. So like on their notes, right, they would see what is super important. So here's a light bulb. And so if you have your phone or if you want to write it down, I'm a picture girl. So take a picture of this. When we interpret standard deviation, we need to make sure and mention a few things, that it varies from the mean, or it says the distance from the mean. Okay. And then we need to make sure and put it in context. The other thing is we don't have to write all this jazz. Okay. Woof, no, not on the AP exam, because we're going to use our calculator for some of it, right? Or we can put it all in our calculator, but to write it again, too much. We have to have our first term, and then we can put the plus, ... plus in the last term, and we would receive full credit on the AP exam. Okay, so that might be a little time saver. You'll need to, of course, not put plus ... plus in your calculator, but on your paper would be fine. All right, questions about the last mini lesson? Questions? Stick them in chat if you have. Okay, because now we're going to move to the next mini lesson on transforming and combining random variables. Okay, so transforming and combining random variables. This is where we're going to add and or multiply. All right, so looking at this, transforming random variables involves either adding or subtracting, that's kind of one pod, or multiplying and dividing. That's our second pod, okay, by a constant. Okay, so the question at the bottom says, do you remember how adding by a constant or multiplying by a constant affects the center and measure of spread? Take a moment to write it down what you remember. Now, I have high school kids myself. You're not writing anything down. It's okay. Just think about it in your head. Okay, we know that paper is not close on a Saturday morning. Okay, so, all right, so we know a couple things. If this is my distribution, and I'm going to stick my thumbs out so we know that it is the same size. And I take this distribution and I add things to it. It just goes boom, right? What was affected? Well, the mean or the center went up, but did the distance between my thumbs change? No. Okay, so let's start over in our second pod about multiplying. Boom. So if we start multiplying, we go, woo! So our distance changes, right? So that's something that even in the AP exam, you can look, add, multiply. Okay, so if you get confused. So let's look about these. Remember, mean and median, of course, are the center. And then we have the interquartile range, the standard deviation, the variance, and of course, you know, the range, maximum minus minimum to talk about. So let's say I have this original set of data. So 6.576, blah, 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 blah. Okay, and I find the mean, the median, the range, the IQR, the standard deviation, and the variance. I give all that to you. Okay, so then let's say I want to add 2 to it. Okay, so that's what all my numbers would look like, right? It goes from 6.5 to 8.5, yada, 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 right? So then this is what would happen to my mean. Even if I stuck all of that in list 2 and did one variable stats again, this is what I get, okay? So we can see, okay, that our mean increased by 2. But our standard deviation didn't do anything. So there's where our fingers are touching. We add, nothing happens to our range, but our something did happen to our median and our mean. Okay, so there we go. Now what happens instead if I multiply by 0.9? Okay, so I've taken all these values and I've multiplied it by 0.9. So in this case, I didn't multiply it but technically 0.9 is a decimal. It's a fraction. It's your second favorite F word, fraction. It's really 9/10. Okay, so we're dividing, right? So as we divide, what is happening? Okay. Oh my gosh, all our numbers changed. Okay, so what happened was our mean and measure of centers changed, and so did our standard deviation. Okay, so there will be a question on the AP exam that has something to do with addition and something to do with standard deviation, and it's going to say, what is it? And you're just going to be like, huh? And you're going to panic and you're going to add. Just put the answer down. We know it, right? You're going to go, oh, just added. I've got my thumb still touching. We're good. All right. So adding and subtracting, influence of center changes. Spread does not. Multiplying, right? It affects both. Okay. All right. So now we have to combine variables. So if we have like a variable by adding means, or if we do the difference of means, and hopefully you're kind of right there in your class where you're doing confidence intervals or maybe smack dab into inference with hypothesis tests, and this is kind of what you're doing. Okay, so let's look at this one. Okay, so this is kind of our guided notes here. Okay, I'm doing pretty good on time. So suppose a high school serves students who live in one of two towns. We've got Valley Center, and then we've got a word that I'm going to just butcher, but it's okay. Escondido. Okay, so let V and E represent an independent variable for the number of students in each town. Okay, so the table shows the mean of students and the standard deviation of students who live in either town. Okay, so find the mean and what does the value represent in context. Okay, so just take a minute, not a minute, take about 15 seconds to see if you can answer that in your head. Okay, so for part A, yeah, we're just adding them together. Boom. In a large sample of classrooms at a high school, we would expect, right? We like that word, 35.7 total students on average per class. Done. Okay. So now, okay, remember expected values. We're not rounding, we're just giving them the answer. This is what we expect. Okay. Oh, let me go back. Well, that's okay, because this is a learning thing. All right. So when we are adding standard deviations, listen close, because we're going to do it in the next hour too. You cannot add standard deviations. You have to get them back to variance. Okay. You have to get them back to variance. Then you get this like mega variance, and then you take the square root to get the correct standard deviation. Okay. So they gave you standard deviation. So to make it variance, we square it. They gave you the second standard deviation. We square it to get it back to variance. We squish those together, then we take the square root. Okay. You cannot just add standard deviations. You can't do it. It's not allowed. Okay. So one of the things I've heard a long time ago is to kind of think about it as Pythagorean theorem a little bit. Okay. So it's kind of the Pythagorean theorem of statistics. So when you add variances, it's squared. You have to get both of them squared. Okay. So maybe that's a way that you can remember. Oh, it looks like my animations are backwards. That's why the answer popped up. So in a large, so this would be the interpretation of the value. In a large sample classroom of the high school, combining the number of students from Valley and Escondido per classroom typically varies from the mean. Remember, that's where our light bulb was, of 35.7 by 4.25 students on average. Okay, so we know that we just add the sums of the means, okay, or we just subtract. Means are easy. Variance, we always add variances, okay? So doesn't matter if it says difference, it doesn't matter if it says sum, we're gonna always add them. All right, how we doing? Do we have anything in the chat? Are they quiet this morning?
They're quiet.
Okay.
Again, if you have questions you don't want to post to the group because you're nervous, you can send them directly to Kelly or myself, and no one will know who asked.
Okay. So can I get a thumbs up or a thumbs down? How are we feeling this morning? Are we doing pretty good? I know this is like a fire hydrant. Like you're drinking from a fire hydrant this morning. Nobody? Oh, I got one thumbs up that I can see. 2. Oh, yay. Oh, thanks, Kyle. All right. Okie dokie. So let's talk about binomial and geometric distribution. So this might be something that you covered in January or maybe right before December, or depending on how your school was back to school at this point. So binomial, if you dust that off, your teachers probably use 2 acronyms, one called BINS and one called BITS with a T. Okay, so we're going to talk about binomial distribution in terms of BINS with an N. Okay, we know that it's binary. It either has a success or failure. Each sample is independent from each trial, are independent from each other. And then we have a fixed number of N's. So it should say out of 20 trials or out of 5 times. Okay, and then the probability of success also stays the same. So in statistics, okay, in your calculator, okay, you are going to hit it in statistics. When you panic, you're going to hit 4 buttons. Okay, the first button you're going to hit is the stats button. Okay, and you're going to refresh your memory, scrolling left or right. Okay, that there's a lot of things that live there. Okay, the second one, when we panic on the AP exam, is second vars, distribution. Distribution sounds like a statistical word. Okay, so that's where we're going to find all our normal CDF, all of our inverse norm, inverse T, binomial, all those things are in there. Okay, then the other panic button that we will hit is the math button, and it tells us a bunch of things, and we can go over to probability. And then last but not least, we're always going to hit second stat plot, and that's where we can graph stuff. Okay, so those 4 buttons, anything that kind of sounds like statistics will help you figure out where your stuff is on your calculator. Okay, so stat, second vars, which is distribution. Okay, also second stat plot, and then of course the one that says math for probability. So there's just a little token here. All right. So the only thing that's different between binomial and geometric is the bins or bits, right? So, okay. All right. So in geometric, it's very similar, okay? But we are going to do it until we have our first success, okay? So, I'm going to teach statistics until I get my first perfect score. That means I might be teaching forever, but that's okay. I like it. So, all right. There's that thing here under distribution, under second vars. We have geometric PDF we use when it's exact or equal to, and geometric CDF when it is greater than or less than. Okay. So here it is again. Wonderful people on the AP exam. This is your formula sheet. It gives you how to find a discrete random variable, how to find the standard deviation of a discrete random variable, okay? How to find the mean of a binomial distribution, how to find the standard deviation of a binomial distribution. And this is, whoops, and this is, oh, heavenly days. And this is something that was added recently, is the mean for a geometric distribution. It's not always been on the AP formula sheet. Okay. All right. So hopefully, and in the Bitmoji that Aaron shared, there was a participation guide. Okay. And then, whoops, heavenly days, we're going to stop here and I'm going to have you do some math. Okay. So I would like you to find free response question 2, and then multiple choice question 5 and 6. So we're just going to do a small portion of them. Okay, so free response question 2 and multiple choice question 5 and 6. Okay, so because of our time limit here, I'm going to go on the lower time of 8 minutes and then about 4 to 5 minutes for free response. So I'm going to set a timer, okay, on my phone to keep us in check. So I'm going to set it for, we'll just say 13 minutes so you can find those questions easier. So free response question 2, multiple choice questions 5 and 6 on your mark, set, go.
And remember, as you work, if you run into any questions, you can shoot a direct message to Kelly or me, and we will give you some assistance.
All right, so let's do like 1 more minute, get it all wrapped up, and then we will start answering it and seeing how awesome you did. Do it. Okay, so hopefully, okay, first and foremost, the stats exam is a doable exam. The statistics exam is a doable exam. Okay, your teachers have prepared you. You just have to use your noodle and get some things out. The good part is, I would say if you're in AP stats, that you make pretty good grades, right? So as long as you make, if you get 60% of this test right, you're going to do fine. Okay. So it's a doable exam, but you have to prepare yourself. So that's why you're here on a Saturday. So awesome, opossum. Oops, let me go the right way. Okay. So with this being said, here was the question. We had our hotel. This is, we're going to do the free response one first. Sorry. I guess you figured that out. But so a hotel, yep, there goes. The stroke happened again. So a hotel manager claims that there is a 15% chance that a person staying at a hotel will be upgraded to a deluxe room due to availability for a given stay. This outcome is independent from stay to stay. Max is a frequent guest at the hotel due to travel for work. He always books his stay for a standard room. All right. So I'm going to launch a poll here for A. Okay, so it says, what is the probability that Max's upgrade will occur after his 4th stay? So I want you, after his 4th stay, I want you to answer it. Is it binomial, geometric, or normal? Binomial, geometric, or normal? Okay, so we got about half of you have answered the poll. So I need you to put geometric, or sorry, binomial, geometric, or normal for question 1. All right. Come on, let's all participate here. Mostly everybody. Can I get it to 20? Can I get 6 more? Okay, now we need 5. Now we need 5. Come on, 5 more to participate. And I'll be happy if I get it to 20. Okay, we got 62%. I need 5 more people. Okay, now we go. Now we go. Okay, now 4. Okay, now 2. Now 2. Let's go. Oh man, maybe on the next one I'll reach my goal. So 17 of you. Okay, so ending the poll, geometric. Okay, here's our results. Okay, so looking at this, well, heavenly days, hold on. Okay, we had the 15% chance. It's independent after our 4th stay. Well, heavenly days. Okay, it is geometric. There we go. It is geometric. Okay, which means, right, not succeeding on the 1st, the 2nd, or the 3rd, right? So here we go. But sometimes after the 4th try. So it would be like fail, 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 and then woohoo. All right. So how did we do that? We would fail the first one. Okay. And then we'd fail the second one. And we felt so we would add all these together and subtract from 1. Okay. Wait, why did I say subtract from 1? So will occur after his 4th stay. There we go. We subtract from 1. There we go. So 1 minus 0.478 because it's after. And remember, our silly calculator reads from left to right. So we have to think about that it's 5 or more. So we could do geometric CDF to 4 and then subtract that from 1. Okay. So bada bam. There's our technology. Oh, heavenly days. All right, there it is. All right, so I'm going to relaunch our poll. Okay, and in the same order, is it binomial, geometric, or normal for part B? And I'm terrified that my whatchadilly won't work. So maybe if I scroll up and get you part B. No, we're just gonna, you guys are just gonna have to look at your paper. Oh heavens. Oh heavens. Oh malfunction. Oh heavens. Oh geez. Hopefully you're getting, oh look, there's 7 people that are paying attention to this crazy show I'm doing here. I'm just showing you the answer. Can I get, oh yeah, oh yeah. Do I have 9 other people that sees my mistake? All right. 9 other people. All right, come on. I need 4. I need 3. Come on, get me to 20. Oh, we got 18. Oh, come on, sleepyheads. Oh, good job. We got 19. One more. I got nothing. All right, we're getting closer. So share results. It is binomial. And if you were just paying attention to my silly scrolling, you would have figured that was good too. So it says for part B, what is the probability that Max's room will be upgraded exactly 2 times in the next 15 stays? So the big deal is that we had a finite number of stays of 15. Okay, so you would have said the word exactly. So we would have used technology. We would have used the word PDF. Okay, if not, you could have written it using the binomial distribution formula and you would have gotten the same answer. Okay.
Kellie, can you talk, you may have already said this, but can you say it again if you haven't, or if you have, emphasizing the importance of labeling when you're using the technology calculator speak?
Sure. So, a lot of times when you are using technology, and this is why we're doing the poll, you will need to tell your AP reader what kind of distribution you are doing. So with the first one, you need to say this is a geometric distribution. With the second one, you need to say it's a binomial distribution. The other thing is, I think that, this is my opinion, that the College Board is being more generous lately with using calculator speak or technology if it's labeled appropriately. So we all have the fancy TI-84s now. And so remember I said, if we go to second bars and we go down, we would find geometric PDF. Okay. Oh, why am I doing geometric when it's binomial? Let me look at it before I tell you what I need you to do here. So binomial PDF. Okay. And so it will say N, it will say P, and it will say X. Just write all that down. Okay. And then give your answer. Now, some of the binomial distribution questions will say, show your work. It's on your formula sheet. You just have to plug and chug. So don't stress out. Okay. All right. So the second thing that we need to do is for part C. Max will stay at this hotel 70 times in the next year. Would you be surprised if he received more than 10 upgrades during the year and justify your answer? Okay. So more than 10, and he's staying 70 times. Okay, we've got 8, 9, 10, 11. Okay, we're up to 13. All right, come on, under a minute. Can we get it under a minute? We got 10 more seconds. Come on, can I get to 20 in under a minute? Oh, I'm stuck at 17, 18, 18. Come on, I got 3 more seconds. One more. Nope, but we did get 19, so that's good. So 19, and we are getting better in terms that it is binomial, because either he got an upgrade or he didn't. Each day was independent from each other. And then the N, the final number was finite, meaning he stayed 70 times. Okay. So greater. So I only know one way to tell my students how to do this problem. Okay. When it's greater than 10 is, we would number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and greater. We would put this on here. Okay. We want the greater, so we have to subtract off this part. Okay, does that make sense? So that's why, okay, it was equal to 10 if they use technology. Okay, does that make sense? So 1 minus this part, because I don't need all that. Okay, so there we go. How am I doing? Oh, I've got 3 minutes. Lord help me. All right, so let's go to number 5. Aaron, we can get, oh, I'll do it. We got rid of the poll. So, oh, heavenly days. Okay, so it says, a soda company is running a sale for proportion in which 12% of all bottles have a free logo underneath. If you buy a 6-pack of bottles, what is the probability that you get at least one free logo? So our answer here, okay, would have been D. Okay. At least one, we would win if we got 1, 2, 3, 4, 5, or 6, right? We're winners. The only time we would lose is if we didn't get any, right? So when we hear the word at least, it's 1 minus the probability of none. Okay. So that's where that is right here. Okay. Bada beam. Hopefully you guys got that one right. Of course, you could use your technology. All right. So the second one says we have ice cream stand. He reports that 12% of the cones that are sold are jumbo size. Okay. You want to see what jumbo cones look like. So you stand and watch the sales for a while. What is the probability the first jumbo cone is on the 4th cone you see them sell. So picture yourself watching them make ice cream. And it's like the first one, nope. Second one, nope. Third one, nope. Fourth one, woo. Okay. So that's how it works on the word exactly. Okay. So it should have been 0.8. All right. So closing and reflections. All right. I've got 1 minute. Okay. So we have introduction to random variables. Hopefully you understand that those are the numbers on the top of your probability distribution that you should refresh your memory in terms of mean and standard deviation. Transformations. Whoa, heavenly days. We've got our hands, right? So if we add our hands, or if we subtract, if we multiply, okay, our range gets larger. So there we go. And then binomial distribution being bins and bits. All right, questions, comments, rude remarks? Are we ready to go to the second one?
You got a thumbs up.
Oh, yeah, I get 1 thumbs up. Okay, woo! All right, okay. Are you ready? Okay.
So Kelly, can we give like a brief like 5-minute break here for people to do what they might need to, and then come back and we'll jump right in?
Absolutely. And then I can get my PowerPoint and everything set up. So that would be perfect. So take a break, potty break.
And then if you have questions, you can go put them in the chat. We can get those right at the top
Absolutely.
of the next session. So hang tight, 5 minutes and we'll resume.
You're halfway through. Every time I talk means that less time that you have to sit. Okay, because I know that you can only retain as much as your hiney allows. So hopefully you got to shake off your hiney for about the 5 minutes and be able to do it for another hour. So today is sampling distribution. I'm going to share my screen. Maybe I'm getting better, but I'm still on the struggle bus a little bit when it comes to. All right, do we have this? Oh yeah, oh yeah. I've lost the chat, but oh well. You're in charge of the chat. I can't find it now. Oh, and this is,
you're good.
Yeah. Okay. So sampling distribution. All right. So here we go. I'm going to run through these in the abbreviated version. So we're going to figure out whether a sampling distribution can be described as approximately normal. Okay. We're going to talk about calculating parameters for sampling distribution. We're also going to see if a sampling distribution is applicable. Okay. And then also we're going to count relative frequency, proportions. We're going to use simulations, our formula chart, all that jazz. Okay. And then we're going to determine intervals associated with a given area in a normal distribution. And then that big word, that I word that we have to use in statistics all the time is the word interpret. Okay. So I would not spend a lot of time memorizing formulas. Use your formula chart, but I would spend a lot of time memorizing how to interpret things like standard deviation and all sorts of other jazz. So just like I said, you'll need your calculator, pencil, paper, and then if you want to print out the participation guide, awesome, opossum. So, well, heavenly days, now I have to find my chat because where'd it go? Okay, hold on, guys. More chat. Aha, I found you, everyone. So if you go to Kahoot, and type in, oh, heavenly days. Heavenly days keeps me from saying bad words, just so you guys know. All right, here is your code. If you guys go to Kahoot, what did it just do? Did it do heavenly wild? Okay, well, it's just the numbers. I don't really know why. Okay, so please go to Kahoot, play Kahoot it or whatever, and there's your Kahoot. It's going to be a 5-question game, and it kind of gives me an idea of how you are doing. Okay, so it says waiting for participants. Yeah, we have Nate. Oh, heavenly days. I'm going to share that screen so you guys can see. All right, I've got Sarah, Damien, Rachel. Oh, Kyle. Aha. All right, you guys are doing a great job coming in. Hot diggity dog. Give me about 1 more minute. I know it's hard to get in here sometimes. And I'm so impressed you guys are using not code names that my seniors like to use. Great job. All right. That's about right, about 19. Okay, so that's about how many participated in the poll. So we're just going to fly with it. All right, so I'm going to hit start. Remember, we're all winners and we're just doing this for fun. Okay, because there's people that are very competitive and I appreciate you because I'm one of those people, but we got this. Oh, good. All right, let me turn on the music because it's not the same without it. I mean, who doesn't like annoying Kahoot music? All right, wonderful people. Okay. So this is your statistics fairy godmother calling. Is 58% above the mean or below the mean? It's above the mean. So we could have canceled out the red and the yellow automatically. Okay. Does that make sense? We're going to learn some good test taking skills too. So 58% is above 50%. So we could have canceled out the red and the yellow. Okay, so just keep in mind we're going to learn some things today. All right, great job, guys. Okay. True or false? Read it carefully. All right. So the kicker here was we see n equals greater than 30, and it's like, yep, central limit theorem, but we only use the central limit theorem with means. So That's where we ooftied, right? So this one said sample proportion. So the answer was false. All right. Here we go. All right. So here we go. So we know even if the distribution is skewed to the right, as long as our sample size is large, then the central limit theorem would apply. So that one is true. Okay. All right. So last but not least, no, there's two more, sorry. Might need your calculator, maybe, or your brain. All right. Hot diggity dog, you used your noodle. Okay. It's okay that not everybody got it correct. Okay, because you used your noodle, because you knew that the height was less than 6 feet and 6 feet was 72, right? So we knew that it had to be less than 50. So a large majority of you knew that yellow and green were wrong. So now we have a 50-50 shot, even if we guessed. Okay, so way to go. So you needed your calculator. We would have found the normal distribution, normal CDF, and we would have got it from there. All right. Okie dokie. Here we go. Last but not least. Now, instead of choosing one player, they're choosing 30. All right. So a couple good things happened here. Okay. So we knew that green was not even an option. Good job. Okay, because it was bigger than 1. And then we knew it was greater, or it was still, we wanted something less than the mean height of here. But the normal distribution was 79. So this one should have been still less than 50%. So we should have been able to take out the yellow too. And then the difference was, as the sample size increases, the variability decreases. So that's where we get 0. And you would have used normal CDF. Okay. All right. So let's see what the podium looks like. 3rd place. Good job, Rachel. And then Tracy. And Zoe, great job, ladies. All right, so I'm going to stop sharing this, and I'm going to leave that, so that and silly music goes away. And then I'm going to try to figure out how to share my screen again. Here we go. All right. I'm sharing it, but I don't know where it is. Now I'm terrified. Aha, okay. Okay, so let me see here. So here we go. Let me move you guys off so I can read. Okay. So wonderfully, ladies and gentlemen. Okay, so let's talk about what is sampling distribution. Okay, so a researcher is interested in the proportion of families represented in a certain school district who earn less than $26,200 a year. So a researcher plans to take a simple random sample of 50 families and record their household income if it was above or below that set amount. Okay. In order to calculate the probabilities and perform inference procedures, the researcher needs to know if the sampling distribution, okay, small stroke again. The researcher will need the sampling distribution of sample proportions. Okay, so the one above or below. And so we have to construct a sample distribution of sample proportions. So the other thing is you need to know the definition of sampling distribution. So this definition of sampling distribution is all possible samples of size, whatever. Okay, all. Okay, so how do we construct a sampling distribution for a statistic? Okay, well, we would need to select a simple random sample. We would need to calculate the sample statistic. And in this case, it was a sample proportion. And then we would need to plot the sample on a dot plot. And we would repeat this for every possible sample of size n. Okay. So the dot plot will be a sample distribution of the statistic. And it will have that thing called shape, center, and spread. Okay, so anytime they ask you to describe something, you probably learned something in your class. Does anybody remember, put it in chat, do you remember an acronym or something that you would use to describe a distribution? Stick it in the chat. Describe a distribution, an acronym. Yeah, okay, so there's socks, right? Or sometimes I call it C-socks, or in my classroom, we use the word cuss, meaning center, unusual values, shape, unusual values. Let me use all my enunciation, shape, and spread. Okay, and so all those are great. So even with sampling distribution, when you have that word distribution, right, you should think about those four things, but in this case, we don't have unusual values. Okay. All right. And I don't want to scare you, but yes, this is about 40% of your exam. So you are in the nitty gritty in your classroom of learning what you need to know, but it's a lot of repetitive stuff. And if you can see how it connects, George, we're going to do awesome. All right. So we have 4 mini lessons today. We have 1 sample proportion, 2 sample proportion, 1 sample mean, 2 sample mean. Okay, so I will try to go fast enough where I enunciate. Okay, but we need to do it to it because we only have 36 minutes. All right, so when we're talking about a sampling distribution for proportions, okay, what we're doing is if you think about a huge swimming pool of Skittles, right? Huge, all the Skittles in all the land, okay? And you've got that one friend that dives in and gets a scoop and then counts out the number of purples and then tosses it back and he scoops it again. And we're just taking this and it's like this crazy distribution. That's what I kind of want you to think about. So what is that shape going to be? Well, it's going to be approximately normal. The center is if we take the mean of all of his sample proportions, it should be an unbiased estimator of the true proportion P. Okay, and then we have our spread or of all of our sample proportions, which is the square root of P times 1 minus P over N. So then we have to see if these conditions are met. So we have to realize that conditions are tied to these three things, okay? They are not separate. We have to do the conditions so we can use these three things. Okay, let me say that again. The conditions are tied to these three things. Okay, so the first one, random sample must be selected. Okay, the second thing is we check for our shape in terms of normality. So it would be n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Okay, so this helps us ensure that the shape of the sampling distribution is approximately normal. Then the next thing we have to do is independence. And independence has to do with standard deviation. Okay, so when we're sampling without replacement, right, we have to make sure our sample size is less than 10% of our population. And some teachers teach it in terms of n is less than or equal to 10% of the population of n, or they take 10 times the sample and make sure it's less than the population. Mathematically, they're the same. Okay, so those things all relate to the shape, center, and spread. Okay, now if you have not used your formula sheet, it was revamped lately, and they were like super nice to you. Meaning they even write out the words sampling distribution for proportions, one sample proportion, and then they give you the mean and the standard deviation of the parameters. Do you see how nice they were? You don't have to remember anything. You just have to plug and chug. So that's where they're talking about making sure that you understand, right? Or can analyze statistics. Okay, so let's look at this one. Suppose 80% of all US teens wear a safety belt when riding in a car. A safety advocacy group selects a random sample of 50 teens from across the nation. Describe the sampling distribution model for the sample proportion of US teens who wear safety belts. Ding, 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 the word describe and the sampling distribution. So I'm going to pull out the words describe. I need center, shape, and spread. But to be able to use those, I have to know if it's random, independent, and approximately normal. Okay, so the random sample was selected, right? It was stated that the 50 were a random sample. So we can use the mu of p hat is equal to 0.8. Okay, so we've taken our condition and related it to our description. The second one is our shape. So 50 times 0.8 was 40, 50 times 0.2 was 10. Since both, right, are larger than 10, it is safe to use normal approximation. Okay, so now there's our shape component. And last but not least, our independence component. So we can use standard deviation would be, it's pretty safe to assume that 500 is less than 10% of US teens. And then we would say that the standard deviation is the square root of p times 1 minus p over n. Are we okay with that? So that's where the description helps us tie the conditions. They're not separate. Okay. All right. So this one's a little bit different because now instead of I shouldn't say different. This one is, would we be surprised to find 35 or fewer wearing their safety belts. 35 or fewer. So in this case, 35 over 50 would be 0.7. Okay. And we would draw that normal model. Now, I will tell you in this presentation, all of the distributions are normal distributions where I have labeled the mean and the standard deviation. Some of your teachers, including myself, use a T or Z distribution. In this case, it's proportion, so we would use a Z distribution and put the 0, -1, and 1. And we would find the z-scores and we would calculate everything towards the z-scores. Okay, so just know that I wanted to show you this way because this is a little bit universal depending on how your teacher presents it in your classroom. Okay, so first things first, you need to draw this graph. Okay, you need to label at least 2 standard deviations. You do not have to label the whole thing. Just label the direction in which you're going. So in this case, it would be fewer. So just label the left side of the graph and then make sure and give it some sort of title or label down here. Then put your information down. Your p-hat was at 0.7 and then shade. Okay. So we will find your z-score and this is your answer if you put it in using the mean and the standard deviation that was given. Okay, so this is kind of the way a lot of books teaches, okay, or some books teach. Others, you would still use your lower bound as -999, but you would have found that z-score to put in your upper bound, and then you would have used 0 and 1 as your mean and standard deviation. Okay, if you were doing a z distribution. Okay, and so we found that probability to be 0.0385. So yes, we would be surprised, right, that our model shows the probability of observing 35 or fewer US teens not wearing their safety belt. Okay, is there any questions so far? Put it in the chat, guys. If you have questions, you can do it just to me or just to Mr. Aaron. All right. So let's look at this one and let's see if you can do it. So I'm going to just kind of set just a little timer and see if you can do it. It says 45% of homes in a large suburban area have a swimming pool. What is the approximate probability of obtaining a random sample of 100 houses in the area in which 35 or less have a pool? So this is a calculator, just a calculator specific problem. Okay, so hopefully you have your answer. Now we're going to use our noodle here, okay? Because not only do I want to teach you content, I want you to have some test taking skills before we leave here, okay? If 45% is our mean, or the mu of p hat is equal to p, right? It's our center. And we want 35 or less. It is less than 50%. So D and E are not an option. Okay, so now we have a 1 in 3 chance of getting this right on the AP exam. Okay, so just using your noodle and not getting panicked. Because even if you come back to this question because you don't know, now you have a legitimate shot of getting it right when you guess. Okay, so there's their information that we have. Our p hat is 0.35. Our mu of p hat was 0.45, and there was our standard deviation. Okay, we use all those numbers. We would draw, so we would know that it's small. Okay, and then we would stick it into our calculator. Why is this going twice? There we go. And we would find it to be 0.0222. Okay. So regardless of the way that your teacher teaches you to do it. Okay. You would find the z-score, your lower bound, and then upper bound, 0 and 1. Questions about one sample proportions. All right, so two sample proportions are the same as one parent sample proportions, but there's two of them. Okay, so all right, so a lot of times it's the difference in sample proportion. So we're subtracting one from the other, like the difference between men and women, or the difference between something proportionally. Okay, because we know proportions are categorical and means are quantitative. Okay, so you're going to tell me that it's the same thing, shape, center, and spread? Absolutely. Okay, so shape is going to be easy. Center is going to be fairly easy. The spread is where you'll mess up. Okay, but I talked about it last hour, so maybe not, because we know that we have to take the variance of one plus the variance of the other, get the variance, and then we take the square root to get the difference. Okay, all right, meaning the standard deviation of the difference. The same conditions need to be met, but the big deal here is they both have to be met. So you have to almost like take sample 1 and sample 2 and do each condition. And we know each condition is tied to shape, center, and spread. So they're just not some arbitrary things, and that both are met. Okay, so both have to be a random sample, both have to be n times p have to be greater than or equal to 10, and then also both have to be less than 10% of the population. Yet again, we're going to really look at our formula sheet. So teachers, and me included, okay, this is the time of year where I really pull out the formula sheet, okay, and I really get them comfortable about looking at where everything is on the formula sheet. So it gives everything that we need to know. We have two proportions. It even tells them that it's the difference, and it gives them everything that they need. So let's talk about this one. Now we have a large suburban area and we have a large rural area. We're trying to see if there's a difference in who has swimming pools. So suppose a random sample of households were taken from each area. Okay, and so we want to know if p hat sub s minus p hat sub r represent the difference in the sample proportion of homes with a swimming pool between the two areas, meaning suburban minus rural. So we're going to describe the three distributions: shape, center, spread, shape, center, spread, shape, center, spread. And to do that, we have to do our three conditions, right? Random, independence, and normal. Okay, so here we go. So shape, center, spread, and we're going to check our conditions. So both the samples were selected at random. So now we can find our center, meaning 0.45 minus 0.2 is 0.25. Okay. Then we need to figure out our spread, our distribution. So we need to say something like, it is safe to assume that 100 is less than 10% of each respective population size. Okay, I have to say something about both of them. Okay, if you feel more comfortable saying, you know, each of them separately, like it's a, you know, it's safe to assume that 10% or that 100 is less than 10% of the population in a large suburban setting, and then you want to say that again for the rural setting, that's fine. Okay, so the big deal here is if we look underneath here, this is a variance. 0.45 times 0.55 over 100 is the variance. And then we have the other variance for sample 2, or the rule. Once we add those variances together, then we can take the square root. And then that's the standard deviation of the difference. Okay. All right. So now we have to describe the shape. Is it approximately normal? Well, yes, we did n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So we had to say, yes, since both samples, right, are greater than 10, it is safe to use a normal approximation. All right, we are drinking out of a fire hose right now. How do we feel about proportions? We're about to go straight to means. Can I get some thumbs up, thumbs down? Can I get an emoji? Can I get an emoji? Are we good to go?
2 people are good to go.
Okay, okay, thank you. All right, I appreciate it. Oh, here. Oh, yeah, okay. Yeah, just give me any thumbs up, check mark, whatever. Look, there's my man Harrison. He's in my class. Harrison's in my class. Way to go, dude. Okay, so, all right, so sample means. All right, so we're going to throw proportions out the window for just a minute and think about means. Well, what are means? Means are quantitative, where it's safe to take an average. Okay, so how do we describe it? Shape, center, spread. Okay, what goes with it are 3 conditions. Well, random doesn't change. Our independence doesn't change. So the only new thing I need to do is make sure I have the right center, or sorry, the right shape condition of, is it approximately normal? So I just have one more thing to learn, not 3 more things to learn. One, making sure one thing is different. All right, so let's see. We know that simple random sample. Now, our large/normal condition, okay? If you're not dealing with proportions, you don't have a p to multiply for, so that one's got to go. So now we have to think about, what does this look like? Well, we know 2 things. It can come from the population is approximately normal. So then the sampling distribution would be approximately normal. You plant corn, you get corn, right? Or if n is greater than 30, we can use the central limit theorem. Okay, so those are the 2 that we can use right now for seeing if it's approximately normal. And then our 10% rule is the same thing, because it goes with our standard deviation. So if you know where things go, right, and why we're doing it, you might be able to remember it a little bit better. Okay, here we go. It's right there on our formula sheet, where the mu of x bar is equal to mu, and the standard deviation of x bar is sigma over the square root of n. Because in this case, sigma is known. Okay, so central limit theorem. Okay, it's okay to say CLT, just like it's okay to say SRS. Just as it's okay to say least squared regression line with letters. Okay, and what this says is, even if the population is heavily skewed or non-normal, so the granddaddy, the parent population where everything comes from, this whole big thing, okay, is not symmetrical, it's okay as long as the sample size is large enough. Okay, so let's look at these 2. Okay, so answer yes or no for example 1. A population heavily skewed to the right and n is equal to 2. Is it normal or approximately normal? Yes or no? I've lost them. Aaron, they're not there anymore. Can you see anybody saying anything to me?
1 person has put an X, so I assume that means they say no. So
Okay.
says no.
Oh, we got another no.
There's
Okay,
no.
okay, now we got some no's. The answer is no, it's too small. No, no, no. Yeah, where we go. So now let's do the next one. It's heavily skewed to the right, but n is equal to 30. Can we say it's approximately normal? Yes, 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 yes. All right, now you're making me feel like you're there. Hot diggity dog. Stay with me now. We only have about 16 minutes. We got this. All right. So here's 3 questions. Okay. And I'm going to leave this on the screen, and it's on the participation guide too. But I want to see if you can answer these 3 questions. I'm going to give you a quick and dirty time of about 5 minutes. Okay. Because we don't have that much time. So 5 minutes. See if you can answer all 3 questions. So let's get busy. So hopefully you were able to answer some of these rather easily. So here, there's that word describe. So we're going to, are the samples, yes, they're randomly selected. The sample size is sufficient, right? Since the population is normally distributed, you plant corn, you get corn. Didn't matter if it was 25. Okay. So 25 seems reasonable to be less than 10% of all the great white sharks, assuming that the population is at least 250 sharks. Okay. So we can conclude that the sampling distribution of the mean lengths of the shark with 25 is approximately normal, with the mu of x bar as 18 and the standard deviation as sigma over the square root of n at 0.25. Okay, so there's our shape, center, and spread, and we connected it all together. Then we're going to calculate for part B the probability that a randomly selected great white shark has a length of at least 19 feet. So ask yourself, how many did they pluck out of the ocean? 1. Okay, so knowing that, we have 18, and the standard deviation would be 1.25, right? Because they plucked 1 shark, okay? Not a whole big sample of sharks, just 1, okay? So then we would find our z-score. Depending on your teacher, that's where you would have chose your z-score as your lower and 999 as your larger, the mean of 0 and our standard deviation of 1 to get this value. Or you could have put the lower value as 19, the upper value is something really, really large, and use the given mean and the given standard deviation to get the same probability. Okay. So the probability of selecting a single great white shark with a length of 19 or more is 0.2119. Okay. So we just have 1 shark. So now we are calculating a probability of randomly selecting a sample of 25 great white sharks with a mean length of at least 19 feet. So how many are we plucking out of the ocean now? We're plucking out 25. So some could be long, some could be short, some could be, so we know that our variability is going to decrease, right? Because our sample size increased. Okay, so our standard deviation is going to be different. Okay, so similarly, we know the mu of x bar is equal to 18, but the standard deviation is changing due to the fact that our sample size is increasing. So here we go, 19 is over here, because if you see, this standard deviation has changed. So if we shade, it's going to be little, okay? So let's say, let me go back up here. Let's say we can draw this, and then we panic on the AP exam. How in the world can I find a z-score? How in the world can I do normal CDF? Well, if you graph and shade and you make a conjecture to the empirical rule saying that, you know, it's outside 3 standard deviations, right? And so there's a tiny little chance you might get partial credit, not full credit, but partial credit. Okay, so we stick this in here. We would know the probability is about 0, which is really, really, really small. Okay, so here is a multiple choice question. It's a calculator-based question. So it says, suppose that bottles of soda are filled by a bottling company, are filled with an average volume of 20 ounces and a standard deviation of 0.4 ounces. The distribution of the volumes is approximately normally distributed. What is the probability that one randomly selected bottle of soda will have a volume of at least 20.5 ounces? So pause before we even do anything. It says at least, so we're shading to the right, and 20.5 is bigger than 20. Someone in chat tell me which two choices can we eliminate? Because we're using our noodle on multiple choice. Which two choices can go away? Someone stick it in there. Okay. So we have some people say, so if we draw a normal distribution and here's the mean and here's the standard deviation, we want this piece, we know it's less than 50%, right? So we can get rid of C and D for sure, and E can probably go too, okay? So C, D, and E, because we know we can do that. So now we have a 50-50 shot. We haven't even picked up our calculator. We've just used our noodle. Okay, so boom. Okay. Are we okay with that? If we draw the graph and we only have these two left, we can kind of use the empirical rule, right? If you're stuck, if not, just throw it in your calculator, right? But if you get stuck, you can think these out. Stats is really doable, okay? Okay, because if this is 34%, then this is 16%, right? And this is 2.5%. So it has to be somewhere between there. So it has to be B. Okay, you can, on a lot of these, you can logically think your way through them. Now, instead of having one bottle, we have 6. So my standard deviation is going to change. Okay. But there's still some answers that don't make sense. C, D, and E don't make sense. Okay. So stick it in chat. Which one do you think it is? All right, so for time's sake, it is A. Okay, so now we're gonna, I literally have 120 seconds. So here we go. I hope by now it's a broken record. Shape, center, spread, right? Shape, center, spread. I hope it's a broken record. Random, independent, normal. Okay, and since it's the difference, when we talk about the difference, have to add the variance. Now, just for the sake of looking at this, we have square root of sigma over the square root of n. And if we square that, sigma squared would be on top. But what is the square root of n squared? That's where they get the n from. Okay, this is not a new formula. They just simplified it. They just didn't put the square root and then square it. Okay. So variance plus variance, they take the square root to get the difference for the standard deviation. All the conditions are the same. You just have to make sure both samples are met. Okay. This is also in your formula sheet. Okay. So, all right, Aaron, I don't know what to do. We were 60 seconds.
If you need to go over a little bit, that's okay.
Are you sure? Okay. So let's go through. We'll do 1 to 2 examples and then we'll get, okay, because I know. So it says heights of mature maple trees are approximately normal. So they told us, right? with a mean of 85 feet and a standard deviation of 18 feet. And then it says mature hickory trees are approximately normal. Thank you. And then it gives us the mean and standard deviation. Suppose 50 maple trees and 40 hickory trees are selected at random. What is the standard deviation of the sampling distribution? Okay. So there are some distractors in here, because if you just take those, right, and add them up and take the square root, it's going to be one of those options, but we're not going to do that. Okay. So we have to make sure, right, that we're using the right information. The 18 over the square root of 50 and 5 over the square root of 40. Okay. And then we're squaring those to get variance. We add those together and then take the square root. Okay. So the answer would be C. Okay. Aaron, this is about all. I mean, it's going to get longer. So hopefully they got what they need.
No, yeah, that's fine. Do you have
Okay.
do you have a wrap-up slide that you want to show, or
Sure, we can. So just make sure and use your, hold on, use your formula sheet when you get confused. I'm afraid if I back out of this, I will never know how to get to the last one. So oh, of course. So here is my wrap-up slide. Okay. In terms of single proportions and the difference in proportions, the only thing is really honing in on what approximately normal is. And then for means and the difference in means, you need to hone in on your normal, what makes it approximately normal, because the independence and the random sample are going to be the same. So any questions for me? I feel like that I talked 1,000 miles an hour. Aaron agrees. That was his agreeing laugh.
There's no way around it though. So
well, I hope you guys had a great time, and Aaron's going to talk to you for a minute.
Yeah. All right. Thanks, Kelly. And again, just to note, if you're working through those free response questions that Kelly didn't have time to explain in the online resources, and you have any follow-up questions, feel free to reach out to her. I'm sure she would welcome your email. You can see the contact information on the screen for Advanced Kentucky, myself, and Kelly. So please reach out to us with any questions, comments. Kelly will take the rude remarks. And as a reminder, the recording and handouts will be posted to bit.ly/ADVKY sometime in the next day or so. Please join us on May 1st. We're taking a little bit of a break, but I realize that this will probably give you a really good time to cover all of this material. On May 1st, Reva Sloan joins us to talk about inference. Inference is a tremendous amount of the exam in the course, but we're going to condense it into 2 hours. So if you thought Kelly spoke fast and had a lot to cover, May 1st, we'll put that to the test. So hopefully you'll join us back then, and hopefully you all have a good rest of the day. So take care, everyone.